So A, with reference to a CCD, state what is meant by a pixel. So if we go to our definitions, we have pixel, a small area of a CCD that acts as a capacitor. So this idea of a capacitor is a device which can store charge. The simplest known one would be if you have two parallel plates and connected to a source, an electrical source, so positive, negative, and this would cause a charge to build up on either side here. So obviously, because this is positive, electrons would be attracted in this direction, and you'd form a positive charge here, and this would cause electrons to be attracted towards this side, and so you get electrons that would be negative on this side. But because you can't get a flow of charge between here, because these are separated, so the charge can't flow to and fro across there, you get a build-up of charge. Now, this happens with a CCD, but the thing causing the buildup of charge is light, and that causes it to behave like a capacitor, builds up charge. And a pixel is the smallest area, so you may get the CCD like this, and then it is divided up into as many parts as it is made, and each part here, each one of these is a small little capacitor, and that is 1 pixel. Now going on to the question, next question says, outline how light falling on a CCD leads to an electrical signal being produced by a pixel. So as I said before, we have the situation that when light falls on a surface, it causes electrons to leave by means of the photoelectric effect. So you've got light coming in here, these electrons leave. Now, because it's a silicon is a semiconductor, so it will allow the charge to flow in one direction, but once it is there, it will remain there. It won't be able to go back. So what basically happens here is that this side over here becomes negative, and because this is leaving, these leave what we call electron holes. These leave holes. This will actually become positive. And so you get this, in each of the pixels, you get this buildup of charge between the two. So you get a buildup of charge. There will actually be a potential difference now across here that will be built up. So going back to the question here, we have outlined how light falling on a CCD leads to an electrical signal being produced. So as mentioned, you get the photons cause the emission of electrons and it forms holes. This change in the potential difference develops across the pixels, so you get what we said here, and the potential difference formed. So as you get this over here, you get the electrons jumping off here, and this becomes negative, this becomes positive with your electron holes. This potential difference here that you get, if you went across there, you get a certain potential difference across there. This would depend on the number of electrons, a number of photons coming in. So the intensity of the light will depend on the number of electrons that actually are emitted. So the stronger the light, the greater the number of electrons that are emitted. Question C. It says, state one other piece of information that needs to be collected in addition to the electrical signal in order that the image is formed. Well, obviously the position of the pixel needs to, so we need to have the position. That's very important, so we know that where that value is. And other things that are important is if we're dealing with color, you'd need to know the color or the wavelength would be important, but the position, if we're just talking black and white photography, the position would be the most important thing. And then suggest 2 advantages of CCDs in comparison with photographic film for image production. So here I just want to call up the PowerPoint for this, and we can just see that. Here we have some advantages of CCDs compared with the use of film. So the cost that we don't have to take it and get developed. We can store it digitally, and we can even print it ourselves. The quantum efficiency of the film is typically less than 10%. So your quantum efficiency with your photographic film is low, and therefore CCDs, which have a higher quantum efficiency, can capture images in darker conditions. Once it's digitally stored, you can enhance them electronically. You can do a Photoshop on them, and you can increase the light and so forth. You can immediately see the image. You can look at it, and also it's easy to store large numbers of photos, films, etc. So that's basically why the use of film has basically disappeared. We don't use film very much. We generally use CCDs to capture pictures.